this will be a programming lecture today, and it will be the last lecture on Scratch. So remember it, because it's about to go away. So yeah, let's get started. I just want to talk about like how do you approach a programming problem in general? Like if I give you something to do and I don't tell you exactly how to do it, like how would you figure it out? How would you make it work? All right. So here's kind of the idea, the program creation process, let's say. So like if I give you or your boss gives you something that they want done and you have to write a program to do it, here's kind of what you need to think about, right? Your goal is always to perform some task, like spit out these numbers or make this website, something like that. So to understand the task and get it to be performed, you have to understand just like what is the problem, what am I looking at, what are the inputs to this problem, and then what am I trying to produce with those inputs. It's always an input to output game, right? So the problem itself, you have to understand like what are the concepts involved. Do I need a loop? Do I need to read an image from somebody? Who knows? And then inputs are just whatever you're getting from the user as your program's running. So what will the user give you? And they're asking ever so nicely for you to use their input to produce something, right? To produce an output. So like your output is always like the thing that you're spitting out. What is the answer that you're giving back? What is the answer? And I'll put answer in quotes because it could be like a web page, a video or something even. What is the answer that your program gives back? So yeah, those are the things that are important. And then the goal is, once you understand the problem, like you're getting these inputs and you're producing these outputs with them, right? So your goal in general is just like take these inputs into the outputs, produce them in that way, all right? That's all a program is. It's just shuffling data around, taking input, producing output. At the end of the day, that's the secret, right? So given these bad boys, you must produce what you were supposed to do with them, okay? And another word for that is an algorithm, right? A sequence of steps to solve a problem. That's what an algorithm means, and that's honestly what's going on. That's why we care about that word in this class. So yeah, let me just like say a problem, and then we'll solve it together. So here's a problem, like your boss gives you this, like I am getting a number from the user, and I like to calculate that number factorial. So n factorial, where n is user input, and hopefully we all remember what a factorial is, right? It's that exclamation point in math, like 5 exclamation point, 5 factorial, that's meant to mean 5 times 4 times 3 times 2 times 1. Okay. So let's make a program that, like, given the 5, produces this answer. It does the math for us, okay? So that's what computers are good at. So again, let's break it down. What are our inputs? What are our outputs, first of all? So I kind of said what the input's going to be. We're getting a number that we want to take the factorial of, right? That's our input. And then also, our output is a number too, right? We're producing like a bigger number, right? Because we're multiplying things. Our output is also a number that we have to produce from the input number. And then the problem itself, like how do we break that down now is the question, all right? So it's kind of how I would think in my mind. Okay, I'm going to take a number. I'm going to find the factorial of it. What could go wrong? And I start thinking about all the edge cases. Like, okay, you can break your problem down into little smaller problems called sub-problems. Like, okay, if the user's giving me a number, and they can type whatever they want, so they could potentially type a negative number. And if we know about factorials, we know that factorials of negative numbers do not exist. So that's a problem. What should we do in that case? We start thinking about these things. Like, okay, maybe we output an error message, and like that's going to involve us eventually using like an if-else block in Scratch, yeah. And then once you've like ironed out all the different ways that things could go horribly wrong, like find a way to like do the real thing. What's the main problem? It's okay, we got a real number from the user. That's something we can actually take the factorial of. How do we actually compute that factorial? Okay. And here's my thought. Is how I might break that problem down. All right, I need an answer, right? I'm getting a number from the user. I'm getting that. Call it n or something. Like that's my 5. And then I need to produce something with this n, so I'll make another variable, right? One called like out for my output. Right? And I'm just going to repeatedly multiply numbers from n into here. I think that's going to be the strategy, right? Because like I want to multiply 5 into out, 4 into out, 3 into out, whatever I want. Okay, so what should I start out as? definitely can't be 0, right? Because if I keep multiplying 5 into 0, 4 into 0, it'll stay 0. So for multiplication, at least, the identity of multiplication, right, is 1. So you want to start out at 1, because then we can multiply 5 into out, make it 5. And then I can just like decrement n, make it 4. Multiply 4 into out. Okay, now it's 20. Make it 3, like that's my next number. You see how that's kind of the game that we can play here with a loop? Then, okay, 20 times 3 is 60. Just like keep building up, keep multiplying into the out variable. Take whatever it is, and then multiply by the next number. Right now it's 2. Multiply my out by 2, and store that back in the out variable. So now it's 120. Then n is 1. Multiply 1 into out. Technically, we could have stopped there because like it keeps it 120. But then like, when do you want to stop? Like, well, this is a game we keep playing, right? So, okay, now n is 0. Do I want to multiply 0 into out? No, that will get rid of my entire answer. All right. So I think that's going to be the answer. So like, keep multiplying n into this out variable and decrementing n. So like, we'll use that variable, make it smaller and smaller because that's like first time it's the 5, then it's the 4, then the 3, and then once n is 0, I do not want to multiply 0 into out, so that should stop my loop. Okay. So that's going to be the goal. All right. Does that kind of make sense how I broke that down? You can kind of see how we're going to do this in Scratch now. Do yell at me if you have any questions, but yeah, let's code this up. I need to be in a web browser. Scratch.mit. So what am I doing? I'm getting a number from the user first of all. If Scratch ever decides to load, that is. This has happened before. I think I just need to refresh it. Yep, and then it's suddenly fine. Alright, so when the green flag gets clicked, what do I want to do? Step 1 is get that number, right? I need a number from the user, and this can be the Scratch Cats program. Give him his real name. So, alright, when the green flag gets clicked, I would like to ask the user for a number, right? Like enter a number, or enter n or something, and wait. And then we're getting that number in this answer variable, yeah? And due to the way that I want to work, I'm going to keep on subtracting from the number that I got, and the answer variable is read-only. The only time the answer variable gets set is through this ask block, so I can't like set this answer variable to something smaller, to the next smaller number. All right, so I'm going to have to like shove it into another orange normal variable that I make for myself, because then I can change it all I want. Okay, so I'll change this default variable's name to n, because that was the variable that I wanted to use, and now I'll set this guy. All right. So then, like, after I get a number, like, whatever that number was, it'll be sitting in this answer variable, right? I want to put it in an n variable, because then I can mess with n. Now I can decrement it. I can do what I want, okay? So, yeah, if I check it so that we see it, and our number 42, do you see how 42 is what's in n right now? If I click it, it's whatever was in answer. We're just moving it. We're just moving it around, okay? So they're both 42 because I'm setting n to whatever answer was, right? I go again, 55. And is now 55. Okay, does that make sense? So I'm just using that variable, an orange variable, because that one I'm allowed to mess with. It's not read-only. Okay, so yeah, let's figure this out. From then, I need also an out variable that starts at 1, right? That's my that's a number that I can just keep multiplying into. Can't start it at 0 or anything. So let's make another variable. Make a variable. I'll call it out for output. You can call it whatever you want. But yeah, I want to, at the start of the program, make sure that that out is set to 1 so that I can multiply into it and it keeps whatever I multiply. All right, so that's a good start. And then I want to loop, right? I want to loop until I'm done. Repeat until I'm done. We'll figure out what it means to be done. But what do I want to do as I loop every time? I want to just keep taking my n value, whatever it was, like the 5, multiplying it into my out value and resetting out to that answer. And then once I'm done, I need to get ready in the next round to multiply the next smaller number, like make n 4 instead of 5. So it's going to be multiply n into out and decrement n. That's the thing I'm repeating, okay? So keep on multiplying n into out. So like set out to be the result of multiplying, I know this is a mouthful, the result of multiplying out by n, right? So that kind of makes sense. Like, okay, reset it to be whatever it is right now, like the 5, or sorry, the 1 times the 5, set that in now, now it's 5. Or if it was already 5, and then it's 4, set it to be, okay, 5 times 4. set that in, now it's 20, okay? So that's what I want to do there, and then I want to decrement n, make it smaller so that the next round I'm ready to multiply 4 and 3 and 2. And so an easy way to do that is to do the change block. You can change out, not by 1 that makes it bigger, but by -1 that makes it 1 smaller. So if I just repeat this the right number of times, I'll get my answer. Now the question is, how many times do I want to repeat this? When am I done? So do you see how, like, okay, I can multiply 2 in, that's fine, makes it 120. I can even multiply 1 in, even though it doesn't change the answer. It kept it 120 for this example. But the second n becomes 0, I do not want to multiply 0 into out, yeah? So, okay, that's my stopping condition. So I want to repeat, right? That's my stopping condition. I like to repeat this process as long as n is, right? As long as n is greater than 0. The second it's smaller or equal to 0, right? Then we're totally done, right? So you can check for that. So that's repeat until n is 0, essentially. Does that make sense? That's kind of what we want to do here. So repeat until n is 0, because it'll work its way down there, and eventually it will be done. All right, so that's going to be my code. I think that'll work. So, all right, 5. Oh no, I did something wrong. It says infinity. That's a problem. So let's see. Oh, sorry, change n by -1. That's going to be what I need to do, right? I need to decrement n, not out. Silly me. And now I get my 120, and I can slow this down so we can watch it work. So let me add a wait 1 second block every time I do something. So now we can watch it change up here. It'll be very small. I'm going to enter 5 again. You can see 5 we multiply, now it's 4, multiply the 3 in, multiply the 2 in, multiply the 1 in, and it's 0 now. That stops my loop and we're done. All right, and this works for anybody. The answer is 120. The factorial of 3 as well, like multiply it in, multiply it in, multiply it in. We're stopping at 0 at 6. That is correct. All right, seems to be working. And then we can, we don't have to make the answer small like this. We can say the answer out loud, right? Say out, right? Out is going to hold our answer out for 2 seconds. So go back to the 5 example. And you can kind of watch it work. It's multiplying the 2 ins, about to multiply the 1 in, not about to multiply the 0 in, so it stops the loop. And it says the right answer. Cool. Any questions about this code and how it's working? How we broke it down? It seems to be doing the right thing for now. Yeah. Now let's talk about the edge case, because watch. If I say, I would like the factorial of -2, please, you see how it's just going to keep multiplying n into out until the end of time, and it keeps oscillating because it's negative, big positive value, because it'll never get to 0. It was already, n started out less than 0. It'll never get to 0. And so it's just huge, very long numbers, large numbers. This will never stop. Now it's using scientific notation because the numbers are so big. So let me stop this. So that was our subproblem, right? If we're asked to solve the factorial of negative numbers, not going to happen, right? There is no such thing. So we should, before we even try to do this loop, right, which may run forever with the wrong stuff, let's just check, right? If the number that we were given by the user was a bad one, if n was less than 0, like that's what it needs to be, right? If n was less than 0. If n was negative, it was less than 0, then we should yell at the user, right? We do not want to continue to this loop down here because it'll just never stop. So let's tell the user you messed up, right? Say factorials of negative numbers don't exist. And then we should not let this loop continue, right? By default, it will just go down and try it. So we would like to stop the program, and I think that's in control, right? Just stop everything if we get to there. So that's going to be our check for our case. So now if I type -2, it yells at me, and it just stops the entire program. So I think that's kind of the best way to do it. There are other edge cases. The factorial of 1, right? That would only loop 1, so let's make sure that that's going to give me the right answer. Yeah, 1 is the factorial of 1. And then also the factorial of 0 in math is defined to be 1. Let's see if that works. Surprisingly, that works, because we're starting out at 1, and we're just going to stop the loop immediately, because n is already 0. So that works out. So yeah, we thought about the different cases, and we solved that problem. So that's the secret. I think that'll do it. Any questions about that? Or I give you another problem to think about. All right. So here's another problem. Let's try this one now. So, okay, our boss gives us this, professor gives us this. What do we do? How do we solve it? So I'd like to sum up the numbers from n1 to n2, where n1 and n2 are two numbers that I'm getting from the user. So, for example, like here's kind of how it would work. If the user gives me the numbers 2 and 7, two separate numbers, then the goal is to sum up all the numbers from 2 to 7. So 2 plus 3 plus 4, 5 plus 6 plus 7. Like I want that answer, whatever it is. Okay. So, all right, let's break it down. What are our inputs? What are our outputs? So I'm getting two numbers from the user, n1 and n2. Okay, that's a start. What am I doing with those numbers? What is my output? I like to sum, right? I like to sum a bunch of numbers up. That is going to be my output. Okay. Still a number though. That's my input. That's my output. And now the goal is, right, how do I take those inputs, produce the output? All right. So that's our main problem. We can also think about, like, what if the user is silly and says something bad? What if they are like, sum up all the numbers from 7 to 2? It's meant to be in ascending order, right? So, like, there kind of are no numbers between 7 and 2. Can we yell at the user? We could say 0, right? Because there are no numbers in that order. It's up to you, the programmer. But that's another thing to think about. There's a sub-problem for us. And then, like, the main problem is, like, okay, we got actual normal numbers. How do we produce the sum from the smaller one to the bigger one, right? So again, I think we can play a variables game, all right? So we're getting two numbers from the user. Let's shove them into their own little variables, not just answer. It's like the user gives me 2 for n1 and 7 for n2. Like, how could I use these and produce a sum, right? Let's make a third variable to hold the answer just like I did last time, out. I think that would be a good one. And I just kind of want to repeatedly add numbers into out, like 2 through 7 somehow. Like bring the 2 in, bring the 3 in, bring the 4 in, add into out. And so if I'm summing up a bunch of numbers, what should I start out as? I guess I said it in the slides, but do you see how it can't be 1? Because that would make the answer offset by 1. Like you need to start, if you're adding in, the unit of addition, right, is 0. Start that as, and then we can not multiply, we can keep adding in like 2, then 3, then 4, then 5, then 6, then 7 into out. Yeah. So that's the goal. And all right, if the first number I want to add into out is a 2, if the user gives me these, how about I just hook into this n1 variable? Like it's already 2. That's perfect. Let's take that and like add it into n1. This is like a strategy, right? Now we're coming up with a strategy. Okay, that'll make that 2. And then the next number I want to add in is 3. I almost have 3 in n1, right? Let's just use this variable and mess with it. Let's add 1 to it. I won't touch n2, but I'll use n1. And then I'll add the 3 in. See, now it's 3. I'll add the 3 in. 2 plus 3 is 5. And then the next number I want to add is 4, right? Add in the 4. That'll make it 9, right? 9. And then the next number I want to add in is 5. So just mess with n1. Just keep adding 1, because that'll give me the next number I want to add into this output. This next number in my sum. Then add in the 5, make it, 14. And then, okay, the next number I want to add in is 6. Do that. That'll make it 20. And, all right, then the last number I want to add in is 7. So keep going. And then the answer is 27 in the out variable. And then, all right, this is kind of like my loop, right? I just keep on adding into out and incrementing n1 eventually, right? This will get to 8, and I'm done, right? I don't want to add this 8 in because that's like more than what I wanted. I just want to go up to 7. And so I can check, right? This variable is my upper limit. I can use that, and I can check against that. Like, what is n1 right now? Is it still less than or equal to that number? If so, I want to include it in my sum. Otherwise, once it gets bigger, right? Once it gets bigger, that is an 8, right? Once it gets bigger than my upper limit, I don't want to add it in anymore. I want to stop. So that'll be the secret. Yeah, I would like to add n1 into out as long as, right, as long as it's less than or equal to that n2 value. That'll just be saved as my upper limit value. And then just like increment n1, like it was 2, the next number is 3, the next number is 4. Right? It'll always work like that. So that's pretty cool. And so we want to keep doing this while n1 is less than or equal to n2. And the second it's bigger than, I want to stop. I want to repeat until, right? Repeat this until n1 is bigger than n2. See that? Because that means like 8 versus 7. Now I don't want to add the 8 in anymore. I'm done. All right, so that's going to be my my little algorithm. Does that kind of make sense? Can we see how that would become scratch code? Do yell at me. We got plenty of time if you have any questions. But yeah, let's try it. Did I save this? Yeah. All right, let me clear it out. Goodbye. And then I'm going to make my 3 variables, right? I wanted 3. I wanted n1, n2, and out. n1, make a variable. n2, make a variable. Out. You can check them to have them being shown, but apparently they're out of order right now. Who knows why? There you go. And then, okay, when the green flag gets clicked, what do I want to do? Boop. Well, I need those numbers first, right? I need to ask for them, like enter n1, enter n2. And then I want to shove them into their orange variables. I don't want to use answer because I can't mess with answer. Okay, so ask enter n1 and wait. And I'll use the answer variable. And I also want to say enter n2 and wait. But if they enter n1, then I want to set n1 to whatever answer was. Yeah, I'm just shoving that right into n1. Now I can mess with that variable. It's an orange one that I can change. And then, cool, I can just duplicate this. And then I can say enter n2 and wait, and then I'll shove that answer into n2. I'll just reset the answer. Now I've got my variables, right? And then finally, I want to set out, right, to the starting value so I can add in answers to it. It wants to start at 0, right? So set out to start at 0. And so that's the start of everything. And now we're ready to do our looping. Right? We've got our numbers, we've got n1 and n2, and we'd like to just repeatedly add n1 into out as long as n1 is less than or equal to n2. Right? So I want to repeat until n1 is greater than n2. So that's our loop again. So repeat until n1 is greater than n2. So that means it's too big. I don't want to add it in anymore. And then what do I want to repeat? It's this process, right? I want to add n1 into out and increment n1. All right, so add the 2 in, then make it 3, so that the next time I'll add the 3 in, make it 4, right? Always be thinking ahead. So, all right, how do I do that? I would like to set out, right? Add n1 into out. So set out, I'm changing out to be the addition, right, of its old value. Its old value plus whatever n1 is right now. That was a thing that I care about adding because I'm not greater than yet. It's one of the numbers I care about. Right? And then I want to get ready for the next round. Like I just added in 2 into out. I want to get ready to add in 3, so I'll increment n1. So I'll change n1 by positive 1 this time. Make it bigger. Okay? And I think that'll do it. Let me just add a wait block so we can watch it work. Wait a second every time we loop. But I think that should more or less work, at least most of the way. So like 2 and 7. Enter 2. You see that it set the n1 right there. Enter n2, 7. And you see out, it's getting bigger. n1's getting bigger. 7. Added in the 7, made it 8. And cool. So it stopped at 27 like we thought. And we should always be outputting the answer, of course. We say out, right, for 2 seconds once we're done. That'll fix it there. But yeah, it seems to be doing all right. Like 2 through 5, let's say. Add the 2, the 3, the 4, the 5 in. Now it's 6, it's too big. Apparently, the sum of all the numbers from 2 to 5 is 14. Cool. Any questions about this and how it corresponds to the ideas we were talking about on the slide? You think you could have done this? Practice if you think the answer is no to that. But okay, it seems to be working for most numbers. What do we want to do in that edge case, right? If the user's like sum of all the values from 7 to 2, like n1 is 7, n2 is 2, like it makes no sense, right? Right now, actually, we don't have an infinite loop, surprisingly. Like, okay, add up all the numbers from 7 to 2. It's like, okay, repeat until n1 is greater than n2. Well, 7 is already bigger than 2, so it skips this entire loop. It's like, Right, the default value of that was 0, it just says 0. That could technically be the answer. That could be fine, right? That could be a valid implementation of that edge case, right? All the numbers from 7 to 2, there are none in that order. So 0 should be the answer, maybe. That's up to you, right? Maybe that's fine. Just let it follow through, let it do its job. What's another edge case to test? Like when we run the loop just once, right? Add up all the numbers from 2 to 2. Does it work? Yeah, it does. It looks like it. Like it adds in the 2, then makes n1 3, and 3 is too big, and then it stops. Cool. Seems to be doing it right. So yeah, I think this is just this original code handled any issues by itself, which is surprising. That happens sometimes. All right. Yeah. If we don't have questions, and please shout out if you do, I think I have a question for you. All right. We got some time. So here's my question for you. I want you to try this. I'll give you this code. Here, I'll zoom out so you can have this all. It's useful code, right? You can maybe change this around a bit. And so I'll paste this here. But I'll make it small, I'll make it bigger so that you can, I'm just trying to show you something. So here's what I want. This GIF is kind of showing an implementation of what I want you to do right now. So I'd like you to try to break down this problem. I want you to ask the user for a number that's bigger than 0. Just assume that they gave you one bigger than 0. And I'd like you to have the scratch cat just start counting, right? Counting from 1 up to that number. So if the user types 10, you'll count from 1 to 10 like this. What number? Enter in 10. You'll start counting from 1, 2, 3, 4, all the way to 10. And then, of course, you stop once you hit 10. Okay? If the user typed 5, then you want to count from 1 to 5. Does the problem make sense? You just want to count up to whatever number the user gave you. All right? So, yeah, think about that. Try to do it. And let me know if you're having any trouble. And help each other, too. But think about, like, what's your input? What's your output? Are there any sub-problem issues that might arise? Maybe if you end early, you can check, like, okay, what if I don't get the right number, the right kind of number? Okay? But yeah, here is at least this code, if you want to look at it, and like here's a GIF of kind of what would happen if you did it, right? I think that is as good as I can do right? Yeah, I think like how many variables may you need for this? If you get the number from the user, do you want to use them? User types 10. The first number you want to print is not 10. But you need to save the 10 so that you know when you're done. So maybe you gotta like make another variable that starts at like 1. Yeah? Those are my hints. I'll give you another minute head start. Let's say. I'll show you how I might think about it. Alright, that was a very loud and obnoxious noise. Alright, so, yeah, did any questions come up as we were trying this that I can answer? Did we get it? Get most of the way there? Alright, like, okay, the input. What is the input? The input's like a number from the user. The output is a bunch of things, right? It's like the user types 10. I want to say something 10 times. So it's like the Scratch Cat's voice is kind of the output, his virtual voice. And then, yeah, the main problem is, all right, we're counting up to 10, and potential problems that we might run into is like if the user gives us a negative number, like, or 0 even, like that's not a number that starts, we can't count from 1 to 0 in that order, right? It's kind of like the last one, you can't like sum up all the values from 7 to 2 in that order. So I think I'll save like what the user wants me to count up to in a variable. Yeah. And then I want to set a variable as some other variable, kind of start at 1, right? Because that's my first number, and I just want to keep checking, like, hey, how does that compare with my n variable? I'll call this like counter or something. How does that compare? Like start at 1, like then print 1, then 2, then 3, then 4, then 5. As long as, right? As long as it's not this yet, right? As long as it's not bigger than that at least. So 5, dot, dot, dot. Eventually, like you'll print 10. Like, okay, that's still one of the numbers I care about. It's still less than or equal to that. But then the second it gets 11, I don't want to print 11, right? Because that's the user type 10. So that's going to be kind of your repeat until. Like, repeat until my counter variable is bigger than my n variable, because that's what the user wanted to go up to, and no bigger. Okay? B and R. All right. So let me speed run that. Did I save this? I think. I'm pretty sure. Yeah. Okay, there was 2. Cool. All right, green flag gets clicked. Here's how I might think about it. I have my n variable. I got my counter variable. N counter. I would like to, at the very start of the program, set counter to 1. That's my first number. And then I also want to set n to be whatever I get from the user. I'm just going to go quickly because we've been doing this a lot. Enter a number to count up to, please, user, and then set n to whatever that was. And then repeat until, right? Repeat until this counter variable is bigger than n, because then I'm done. So repeat until counter is bigger than n. Oops, I'm going to need one of these guys. What do I want to do? I would like to shout out the current value of counter, don't I? Like say whatever counter's value is right now. So like it starts at 1. Say it quickly, though, like half a second or something. Like say the 1, and then the next time I come back around, I want to make it 2, right? So change counter by 1, and then it still should keep working, right? So if I say 10, there it goes, count up to 10. 8, 9, 10, and then like side quest. What if they type -2 or something? Then actually we stop, which is good because counter being 1 will already be bigger than -2. So actually, this code just does it all for us. Count up to -5. There's no need. Count up to 5, though. 1, 2, 3, 4, 5. Cool. That seems to work. I'll give you that, too. Does that make sense? Is that kind of what we got? Maybe there's another way. I don't know. You can do the same thing a million different ways in this class. So, yeah, if we're good, I just want to show you, like, one of the last things in Scratch that I haven't shown you yet. It's called custom blocks. And just for fun, I'll let you try this one yourself. Make that one. I want to do this one. If touching paddle bounce. Because, you know, we were doing Pong, right? We were doing Pong, and we did the bouncing like this, right? We said just bounce off that way. But really what we should have been doing was bouncing that way. And if you go back to our Pong code, like we were doing something disgusting. We were doing something like, all right, look at the ball. Where is it right now? Is it touching a roll? Is it touching the paddle? We had this nice block that was like if on edge bounce. Like that was just like packaged deal. Like it did the bouncing of the ball for us if it was on the edge. We had to code up ourselves some like big long if block asking like, okay, did we hit the paddle? If so, let's mess with the ball and its direction. So wouldn't it be nice if we had like an if touching paddle bounce block? We can have that. So that's what we're about to do. It's like, all right, when the ball's coming in this way, like have it bounce off that way. Like we're gonna make a block that says this. That's what we're gonna do. All right, that is the goal, and that will just make things cleaner. We still have to give code for this. We have to say what this block means whenever it runs, but we're gonna make our own block with its own little name, and that's gonna help us break down our problems. Right? Cool. Break down problems into smaller pieces. That's the goal of this lecture, right? Into smaller pieces. And in Scratch, one way to do that is like to think about it in terms of little blocks. Like if I had a block that did exactly what I wanted for this small part of my problem, that would make my life easier. So I'll just pretend I have it for a second, then I'll go say what it means, right? So let me load our Pong code. And I don't remember which lecture it was. I assume it was our last programming lecture, lecture 8. Okay. So if I load from my computer, lecture 8, in theory, the last thing I touched was Pong. Cool. Yeah, so we got Pong. And if you remember, this was our weird check right here. Every time, this is the balls program right here. This is our weird check to see, like, okay, if the ball's on the edge like it was just then, it bounces just fine, like it bounces flat. But then we also have to keep track of, is it touching the paddle right now? If so, do its little turny turn. So this wouldn't be nice if it didn't, like, that's a little ugly. But if it looked more like if on edge bounce, that's the goal. Okay, let me lose. So we can do that. Let me show you how it's in. This is the last piece that we've never been to yet. It's called my blocks. We can make a block. All right. Here's the goal. I like to make a block called if on edge bounce. Or sorry, not if on edge bounce. That's the one that's already there. If touching paddle bounce. Wouldn't that be nice? And then it makes this thing called a define up here. And then it also gives me this block, which I can use anywhere in my code. I can have a million of them. It doesn't matter. But I also have to say what it means whenever it runs. That's what the define means. But like, let's say we've got it. Let's pretend we've got it. So instead of this disgusting mess, we can just say this. If on edge bounce for the ball, if touching paddle bounce. Is that not the cleanest thing in the world? Like, that's amazing. That's beautiful. That's very easy to read, easy to understand, right? We can have it. We can have our cake and eat it too. We just have to say, like, okay, we've made this block. When it runs, what should we do? What's the code involved? That we can, like, hand off to our future selves. Does that kind of make sense? Like, this will run. We have as many of these as we want, by the way. You can duplicate these blocks just like you can duplicate any other block. We just have to give meaning to this block now. All right? So, to give meaning, here's kind of how it works. When this block runs, it's going to jump up here to this define kind of event. And anything that we hook into this will be run whenever that block runs. Okay? So, like, what does it mean to check if you're touching the paddle in bounds? Well, something like this. So kind of what will happen is whenever this block sees that it needs to run, it will jump up here to the define part and start running all this code. And so that's exactly what it was before already, okay? So let me kind of put it sideways so you can see both at once, more or less. Like that's where I put it, and like it'll jump here and just run this code and go back. So it's still the same. But it's so much easier to read the main code for the ball now, I think. I hope you agree. Isn't that cool? It's like that's what the ball is doing now. That's quite nice. All right. Any questions about this block? I made this block. I'm just gonna run. It's gonna, all right. Whenever it runs, I also need to say what happens, or I need to give meaning to the block. But like, this just makes it so much cleaner in my mind. Like we've broken down the problem. Like, okay, what does it mean to check if you're touching the paddle in bounds? Okay, it just means this. And so like, I don't have to immediately see that every time I'm trying to figure out what this code is doing now, which is cool. It's in a different part of the code. So now let's solve this problem. So we did it this way. Like if the ball comes in this way, we bounced off that way. But really, if the ball's coming in this way, we want to bounce off that way, or vice versa, right? If the ball is coming up this way, we want to bounce off that way. So let me show you the secret if you haven't figured it out. So okay, let's say the ball again. Let's say it's coming down this way. It's like negative 125. That's its direction right now. So if it's coming down that way, we want it to bounce off that way, right? Let's try and pretend and see what direction should it have been. Oh, like +125. All right. If the direction is this, like it's coming in to the left and up, so like negative 48 coming that way. That should bounce off, right? That way. What direction is that? Positive 40. Ooh, the Scratch people were nice to us here. So it looks like if I just take my current direction, like it's coming in that way, I want it to bounce off this way. If I just take my current direction and flip it, multiply it by -1, as far as Scratch is concerned, that's going to be with the direction I want to move off in. So like I'm coming that way, negative 130. Like we're going down and coming off positive 130. See, that's the opposite. Mirror image of the direction. That's pretty cool. So yeah, instead of turning exactly 180, just like negate your direction. If you're coming in, right, negative 90, go off positive 90. The Scratch people are very nice to us, including this. It's not just 0 through 360. The negative stuff, the negative angles are helping us here. Cool. So yeah, that's the secret. So instead of this, we don't want to do that. We would like to, I guess we just want to point in an exact direction relative to my current direction, right? You can get your current direction like this. What is my current direction? It's that weird looking thing, apparently. And we can point in direction involving that, right? We can change our direction to whatever our old direction is times like -1. That'll be the answer. Oops, not quite. And there we go, times -1, and that's exactly the angle that we need. That's beautiful. So watch it work. Oh, that's so satisfying. So that's the right direction. That's the right direction to go off in, and it seems to be working. If touching paddle bounce is bouncing just right now. So that's super satisfying, I think. And like that's a working palm game now. We can still lose. And if it's a different angle, that's a bad angle. It will still work, and it will bounce off in the correct way, and everybody's happy. Cool. Any questions about this? So that's like a nice end to the story, I think. So you can make custom blocks, and you can say what happens when you run those blocks. Definitely play around. You can make blocks that involve input, like you can add like a number as a possibility, like give it a number, give it like a Boolean condition, a square thing, and like have it work with that, and you'll have access to that in the define. So it's fun to look at and think about. There's more to it for sure, but that's enough. That's Pong. All right. So yeah, a couple more things, and then I want to talk about like assignments and tests and stuff. Well, let's talk about state machines. Let me show you something cool. So let's actually program those state machines that I was talking about before. Okay. So just like you can make count the number of words, right? State machine. You can make is a number that you're typing divisible by 5 state machine. That's like an easy one. So let me break that down for you. Let's pretend that the user is giving us a number, and like we are seeing the number coming in from their keyboard. We're seeing each individual digit that they press. So if they press 5, for example, then we think that, okay, the number that they have so far is just the number 5. Oops. And it is divisible by 5, of course, right? But then maybe they type the 1 key, and now they've built up the number 51, right? And now suddenly it's no longer divisible by 5, right? And then they type the 0 key, and now they've built up 510, right? They're giving us a number, a digit at a time, and now it's suddenly divisible by 5 again, you see? And then if they type like an 8, now they've typed in 5,108, it's not divisible by 5 anymore. But if they type a 0, now it's suddenly divisible by 5. So, like, what's the secret? If somebody gives you a number, like, how do you know immediately, like, 1's divisible by 5 and 1 isn't? What's the trick? It's a multiple of 5, right? How do we discover if a number is a multiple of 5? Just by looking at it. Like, I know this one is, I know that one isn't, I know this number that I built up so far totally is, but if it was 5,108, right? Totally not multiple of 5 anymore. What is it? We know how to see it, don't we? Yeah, good. Just like whatever the last number is, if it's a 0 or a 5, you are a multiple of 5 for sure. Does that make sense? We've seen that trick before, surely. So we can turn this into a state machine, right? If we're getting a number digit at a time, we just look at the last digit, and that will move us around, right? We'll have a we're not currently divisible by 5 state. And then we'll have a we are currently divisible by 5 state. I hope that makes sense. And like if we type no digits yet, like the user's sitting at the keyboard, the number is not yet divisible by 5 because there is no number yet. So that's our starting state. But if the user ever types, like if they type a 5, like that means they built up just the number 5 so far. If they type a 5 or a 0, honestly, then your number that you built up so far is divisible by 5. And so you transition in that way, right? If they type like the first digit is 1 or something, then they're like, oh, you're not divisible by 5 yet. So let's think about this. So, okay, that brings us here. We're at 5. Then the user types a 1, right? 51 now. That is not divisible by 5. So if you see something that's not 0 or 5, then that's going to move you into the not divisible by 5 state, right? But if you type a 0 right after that, now you're back. Now 510 is divisible by 5. You see kind of how you're building it up. And if you type the 8, you're going right back here. You type the 0, you're flip-flopping, okay? If you type a bunch of numbers, like if you type 18, for example, you start here, and then the 1, right? The number is just 1. If you type just the 1 digit, you see not 0 or 5, you stay, right? You're not divisible by 5 still. Like just the number 1. And then if you type, then you're in that state, you type the digit 8 to build up the number 18. You're starting not divisible, and you're still not divisible, right? You keep saying non-0 or 5 digits. All right, same with that. And then like if you give like the number 50, you type the 5 first, like that moves you here, and then you type the 0 second, you're still divisible by 5 as long as your last digit is a 0 or a 5, right? So that keeps you there in the divisible by 5 state. Does that kind of make sense? So if you get a number, a digit at a time, you can run the state machine, and it will tell you, like based on where you currently are, here or here, if the number you've built up so far is divisible by 5 or not. Yeah, that's the secret. If it's a multiple of 5, that's another word for that. And so, how do you implement this? How do you turn this into code is the question. Well, we just have to kind of keep track of which state we're in and then keep getting input. So the answer is just use a variable. We'll use a state variable to keep track of which state we're in. Okay? So if we see, let's say that we encode this state as like the number 0. If the state variable is set to 0, that means I'm in the not divisible by 5 state. And if the state is set to 1, let's say, that means I'm in the divisible by 5 state. And I'll just like keep changing this. Like if I'm here and I see like a 5, then I'll transition to here and change my state. So keep going back and forth. And then I can just like after the user's done typing, they have the full number in there by then, and just look at the state variable to say, oh yeah, it was divisible by 5, or no, it wasn't. Okay. So that's the secret. Let us code that up. It'll be once we're in a state, right, we're going to get some input, and then we're going to check, like, okay, was that digit a 0? Was it a 5? Was it not a 0 or a 5? It's going to involve some if else's, okay? So I think I saved that. Let's go one more time. Let's start over here. And, okay. I would like to, when the green flag gets clicked, I'd like to make a state variable to keep track of which state I'm in. And the initials, the starting state, is going to be not divisible by 5, which I'm encoding as the number 0. So 0 is my starting state, set it to 0. And then I just want to keep running my state machine. I want to get a digit at a time, and I'll just ask the user. So ask, enter the next digit of the number. So we'll get a digit at a time from the user in through the answer variable. And I think we can just keep the answer variable this time. But I just want to keep repeating, right? I guess kind of until the end of time. Like they can tell me when they're done, right? They can just stop the program when they're done, I guess. So just forever ask the user for the next digit of the number, and that will be sitting in the answer variable. And just for fun, we can show the current value of state. I'll keep it there. All right. And then based on what we've got, right? The user, maybe they just typed a 5, for example. They either, right, based on our state, like if we're in state 0 or 1, we want to do something, right? If we see a 0 or a 5 or a non-0 or a non-5, right? If we're in state 0, like, okay, did we get this input or did we get this kind of input? Or maybe we're in state 1, did we get this input or this kind of input? If so, we must transition, okay? So there's going to be a bunch of if-else's. So, okay, the first step is like, okay, based on which state I'm in, I move around potentially differently. So let's check. Let's check and see which state I'm in right now. So if state is 0, if state is 0, how do I, because that means I'm in the not divisible by 5 state. If state is equal to 0, then, let me comment this. So 0 means not divisible by 5, 1 means divisible by 5. Okay, so if it's 0, then I know I'm here. I just got a digit and my state is currently this. Like maybe I just started. And I got some digit from the user. I got either a 0 or 5 or a non-0 or 5 digit. Okay, so now we just have to check what's in answer, right? Because that's where that digit was. The user gave us a digit, it's sitting in the answer variable, and that's going to tell us how we move around in our state machine. So it's going to be an if within an if. You'll have to bear with me here. So, okay, now based on the answer, right? If it was a 5 or a 0, I do something. If it was not a 5 or a 0, I do something completely different. Okay, so I'm running the state machine. Maybe I type the 5. Then I need to like have an if again to check like, okay, was it a 0 or 5? If so, I'm going here. So yeah, just like it's good to look at the slides as well as this code at once. I'm sorry, I cannot show you both at once. So if answer was equal to, this is how you check if it was 0 or 5, by the way. You can check, okay, was answer equal to 0? Oops, not 500. And then you can also separately check, was answer equal to, oops, I do not want to add a comment. You can separately check, that's the one I want, if it was equal to 5, and you can see if either one of those was true. So that's an or. So was answer 0 or was it 5? That's how you check that, if it was one or the other. Either one's fine. Both of them mean we're divisible by 5 now. All right? So if that is true, this is going to get very ugly and large. Then, all right, if state was 0, and then we just saw that answer was 0 or 5, what does that mean? That means we're here, and we saw this, and we want to move to here. What does that mean inside of our program? It means our state has changed. Our state variable needs to become 1, because that's how we're encoding the divisible by 5 state. All right? So that's the secret. And so, okay, in that case, we will set our state to 1. We're going to transition, right? And then otherwise, the else case means it wasn't 0 or 5. It was non-0 or 5. In that case, I just want to stay in my same state. So technically, I just needed an if, honestly. I didn't need the else part because the state is technically 0 right now. If I am here at all, state must have been 0. You see that? So you can just you can have the else be empty, or you can just like, for fun, you can set state to 0 even though it already is 0. Technically unnecessary. Technically unnecessary. So there's ways to clean this code up for sure. I'm just showing you the way that you can just like, without thought, translate it. State is already 0. Alright, so that was that case. So if our state was 0 and we saw a 0 or 5, we went to here, like we just coded that transition, and we just coded that transition based on if we were here. And now we have the other flip side of the coin. Maybe our state was 1. Right? That's the the else case here. So if state wasn't 0, we go to the else. That means state must have been 1, right? And I can only add one comment per thing. So, all right, state must have been 1 right here. And then what do I do? Now it's okay. If I see 0 or 5, I keep my state 1. And if I see not 0 or 5, that was that transition, then I go back to state 0. See that? I'm not divisible by 5 anymore. So, honestly, it's just this all over again. Boop. This comment is now wrong, though. Because if I'm here, the state was 1, and then if I see a 0 or 5, that means the state is, like, set it back to 1, it's already 1 in that case. It's like that was that transition. Keep the state 1. Otherwise, if it wasn't 0 or 5, it's no longer divisible by 5. So I'm following this transition back to that one. All right? So that is the full code for the state machine, and it will work. So if I type the number 51,080 a digit at a time, type the 5, okay, divisible by became 1. Okay, yeah, that's divisible by 5. 51,000. Okay, now I've just put the number 51. It thinks it's not divisible by 5 anymore. 0, 8, 0. And you see the last thing we end on is state being 1, which means that the number that I built up so far is a multiple of 5. All right? So this is a lot of code. This could be cleaned up because this if and else, like it didn't matter if state was 0 or 1, honestly, because you're doing the same thing in each one. So you could have cleaned this up, and I highly encourage you to do so. You can actually just have one of these and like get rid of this outer if else. So think about how you could improve on this code, but this is one way to do it, just without thought, just like, all right, either I'm here or I'm here. If I'm here, check this transition, implement that transition. Else, if I'm here, check this condition, or implement that transition. All right? That's how you do it. That is the secret. Any questions about that? That's a divisible by 5 state machine. Cool. It's hard to even show it to you. But yeah, let me see that. So let me show you this. Let's take a minute to discuss with the people sitting next to you. You don't have to think about, or you don't have to code this up at all because I know it takes too long. But, all right, given this idea of like, okay, it's pretty easy to make a state machine that checks to see if a number that you're inserting digit by digit is a multiple of 5, there's almost as easy of a way to make a state machine that checks and sees if a number that you're typing in one digit at a time is a multiple of 2. Isn't there? So try and think about, like, if you're giving a number one digit at a time, how would you implement a state machine? How would you change this? Like, how do you know, like, 18 is immediately divisible by 2, 510 immediately divisible by 2, right? You get a bunch of options. 81 is not divisible by 2. 47, not divisible by 2. How do you know? And say that you're getting a number one digit at a time. Getting that one, then that one, then that one, then that one. Right? You see it? See what you would change? Just stare at that for a second. And we'll see if we're on the same page. What's the secret? How do you know if a number is immediately divisible by 2? It's even, right? Even versus odd. Can you do something similar? Are we just shy today, or do we not get it? I need to know. One of the two, please. So do you see how, like, all right, it's just the last digit, right? It's the last digit all over again. It's an even number if it is, the last digit is even. Yeah, 0, 2, 4, 6, or 8. We all know this. We're just shy to say it, right? Okay, just making sure. All right, so instead of this, like, you can kind of do the same game all over again. You just be like, okay, 2 and 2, right? It's like, all right, if I see a 0, 2, 4, 6, or an 8, like that's going to be my transition. You see that? Versus 1, 3, 5, 7, or 9. If you're building up a number one digit at a time, it's like, was that last digit even or odd? That controls the even or oddness of the entire number. All right? So yeah, that's the trick. I hope that makes sense. Please yell at me if it does not, so I can explain more. But I think that's all that I wanted to say about this. Any last questions before I switch gears to other things? All right. That was the last slide for these. This is our last set of slides about Scratch. So get in the mental mindset to be ready to do things other than Scratch. I do believe I saved this. We'll find out. All right. So let me give you a programming assignment that's going to be due a while from now. That'll be your first thing. This will be your last Scratch assignment. So let's go out with a bang. Here's your Scratch assignment. If you're one of the people doing the Scratch stuff. So, all right, what I'd like you to do is just like do whatever you want, honestly. I'd like you to implement any program that you want as long as you implement these requirements, right? I would like you to make a program, potentially a game, right, that has at least 3 key press events. So do something. Somebody needs to do something with 3 separate key presses, like move up, for example, when the up key is pressed. Like that's 1. That counts as 1, maybe. Do 2 other keys doing stuff. All right, 3 key press events at least. I also want at least 2 conditional blocks, so like an if then else, or just an if then counts. At least 2 of those. It's like check if the ball is touching the paddle, like that was an if, right? So I want to see 2 condition checks so that like you're checking interesting things. And then I also want to see at least 2 loops, 2 looping blocks, like repeat until, forever, anything like that, all right? Like we were telling the ball in our Pong game to move in our current direction forever. Now those are your hard requirements for your program. Hopefully you can think of something cool. I'm excited to see what you come up with. It's always fun. The only last requirement the thing you can't do is you can't copy anything we did in class. Like you can't just remake Pong or something because that's way too easy. I'm giving you the code, right? So you're totally welcome to build off my examples, like do something cooler. Like maybe we've seen like there's a game called Breakout where like your ball like it's Pong on the bottom and it's like the ball is moving and hitting blocks and the blocks go away. Like maybe you can change my Pong code to make that or something. That's a thing. Just don't copy something that I did or something that you already did in a assignment, right? Something new, please. But yeah, does that make sense? That'll be your assignment for my Scratch students. And then to submit, I want a video as usual. I want to hear your voice. Okay, so go over your code. And this will be a bit of a longer video because there's no hard requirements. I need you to explain everything to me, right? Because I don't know what you're doing. I want to see every piece, right? Show me your code and explain what you're doing. And yeah, I think that's all. So good with the Scratch part of the assignment. So that'll be due week 9. So you got plenty of time. And if you are one of my programmers already, one of my people doing the Racket assignments, here is your assignment, all right? These chapters and these exercises from the chapter, or from the sections, okay? And again, I want to see a video and show me what's going on. Right? So I think that is what I want to see. So you got a couple weeks to do it. Yeah, those are both the assignments. We good on that? All right. So that's the first thing. Make sure to do attendance. It looks like I never stopped that. I'll stop that in just a second. Then the last thing I want to say is you have a test coming up. So I promised that we would have our midterm week 8. We're in week 6 right now. Let it be the latest possible day it could be. So week 8, I'm going to release this midterm info page on this midterm module right now. So week 8 is when it's going to be. It'll be Wednesday. So it'll be legitimately 2 weeks from now. All right. So this one, boop, boop. So the 2nd of October. That's when it's going to be, and here is some information about that midterm. During class time on the 2nd, it will cover things up to week 7, and then I'm going to ask you to do like stuff that I've asked you about in class, that you've been doing in your program assignments and your essays. I will have you write, what is it? I'll have you write a little mini essay in class, okay? Just to get some of the words that we're required to write this semester out. So you're going to have an essay question, prepare for that, and then, yeah, here's the rest of the format. So like there will be some multiple choice and short answer questions, and then an essay question, all right? So like read this. That's the kind of stuff I'll be asking you on. I do want to say up front, it is impossible for me to ask you to write a Scratch program on the midterm. There's no way for you to put the code in Canvas, okay? So I'm not going to ask you to write code, but you may be forced to read code or do other things, all right? But the least that I can say is that here's a little cheat sheet. Expect to see questions about this thing, all these things on this little cheat sheet that I've made for you. Wink, wink, all right? So here's some logical operations and their truth tables, wink, wink. Here's some logic gates. You can use this as you take the test, all right? So expect to see stuff on that. And yeah, the last thing I want to say is the test is totally open book and open notes. You can use the internet. You can look at the slides, do whatever you want. The only thing you can't do is talk to another human or AI or something silly like that. You can ask me questions about the questions. It'll be open book and open notes. That'll be the midterm 2 weeks from now in this room at the same time as class. We'll just have one lecture that week, and that'll be on the Monday, right? And the entire rest of the Wednesday will be for the midterm. Okay, so yeah, I think that's everything that I wanted to say. Any questions about that? Does it make enough sense? So yeah, 2 weeks from now, we're going to have a test. Mentally prepare for it. And yeah, I think that's all that I wanted to say.